fog computing, right? So you just see, I will click on fog computing. Fog computing is that. This is the work. Okay. All this coming through the database with fog computing, fog book, fog computing for 10 years. What are the research has been doing from last 10 years? Fog computing, LLM, all of you know about LLM model, large language model. So fog big data analytics, fog queuing, fog serverless model, all has been there, right? This is where research criteria how you can use your things. Okay. Then you can also see the geospatial journal master means what are the journal I have published in 2020 to 24. These are the my work, right? Serverless manuscript, BS GeoDNet, blockchain based serverless computing. All this master data has been there. So you can structurize your work in such a way that in a single click you can find out. Then all if you are doing, whenever you do the heavy research, you have to focus in one literature review section, right? So whenever you do the literature review, just see, I will tell about one. One of my students is working geospatial cloud computing, right? Spatial cloud computing box, right? So he has published one paper here, SDG4. This is the SDG4 what he has done, NRF work. This is a data set. So this is the literature review, right? How can take the literature review? See, geospatial cloud computing. You have to store it like this. What is that? You understand this one? What is that? All these papers has been year-wise, sorted with year-wise, and this is your title of the paper. So I have stored all these papers from 2013 to till now, right? So one thing is that I am preparing for this FDP. I have in every month I have one FDP. In February I have also one FDP from NIT Warangal, maybe, and another FDP in the Central University of Odisha. In every month I have been going for one FDP for that. Wherever it is 1 day, 2 day. I am the listed one of the trainer by the by geospatial governments. They have given me the listing of 25 people. I am included on that also. 21 days geospatial winter. You know winter workshop. 21 days free. 21 days workshop is there every day on 21 days. Only on geospatial technology. I am also going there for 5 days, for 3 days. It may be quantum GIS. You can study for 6 months also, for 1 day also, for 21 days also. For 21 days also we have QGIS components also there. Okay, they can integrate with the machine learning. So many machine learning work also you can put in a quantum GIS. But my area is purely on that cloud framework, right? So I am just showing another thing that during these preparations, this is being work so FDP preparations. For that, for this FDP, I have prepared for this. This is the one FDP related papers, right? So I will share these related papers for you. Sorry. This is related papers, and this paper is purely. I am so much fortunate that this paper has been written by the father of cloud computing, who is Rajkumar Bhuya, along with our IIT professor Sudeep SK Ghosh, Soumya Ghosh, and he has okay. And this paper, right, in 2020, but I have written in 2014, 14 to 16, right? So they have using this one, geospatial fog computing, spatial fog. This is because they are scholar, and Rajkumar Bhai is also there from University of Melbourne, right? He is being one of the highly cited, number one highly cited authors as per the Web of Science, right? And see, he has given 3 to 4 to 5 papers of mine. How? See, this is my first paper. This is from IIT DHU. Okay. This is the another paper he has taken. Okay. in 2016. 18, published in 18, but it is in 2016 because at that time Springer it will take around 1.5 years. This answer, this one also, right? 3 papers is showing, but another also paper is also there. This one also be 15 and 16, and 3 papers has been taken. Okay, in 2016 itself, right? So this is also one of the key area, right? Okay, so we'll go for the next about this architecture, right? So to implement all these SDG4 related things, geospatial techniques. So what are the geospatial computing paradigm is that we have to know about this, the technology which is be meant to solve these problems. These are the main components, right? So first one is that we'll have to study about geospatial web services. Before geospatial web services, we have to know about some fundamental concepts of geospatial data. What is GIS? Simply GIS. Why it is purely GIS is not nothing is to one system. System which is integrated with number of components. I will tell that. And then after knowing about this GIS, geospatial data, then you go for the geospatial web services. Means everything if you can sharing some data with the web, you require some web services. But particularly whenever you talk about GIS component or geospatial data sharing mechanism, we require geospatial web services. Everything is related to web services, right? Then web services rely on this SOA to serverless. Then we have Internet of Special Things, geospatial big data, and open source GIS, right? So simply if I will talk about geographical information systems, GIS, it is the combination of this hardware. Hardware is very important. Very in GIS work, you require high-end hardware mechanism also be required, right? Then integration of software. For example, your Quantum GIS, maybe your Oracle Spatial, maybe IoST, maybe PostgreSQL. All these software is to be required. Then data is also the important part. For capturing, managing how to manage to store the data, analyzing and displaying, very important. Visualizations of that data is very important for the concept of GIS, right? All to be clear. GIS is nothing else. It is the combination of hardware, software, then your data, then is your hardware, software and data, and also one of the important factors also be here is that users. Because if I will tell about somebody, those having unaware about the component, how they can handle. So users also very important, right? So exactly.
Which type of hardware components are required?
Means high-end hardware for example, you cannot do in Pentium machine. You require some of the high level of IPSM processor also be required. Memory devices is not required, some simple it is be required high-end memory. For example, ma'am, also telling that the one image they are capturing, it is 1 GB of data. Maybe 100 GB of data they are capturing each and every time they are capturing satellite image, they are storing in their memory devices. Isn't it?
Is
So
there any specific type of components or specific?
no, simple no. There is no any, but it is required high-end processor systems. Okay. Then GIS also allowing you to view, understand, question, interpret, and visualize the data in many ways, which is be using for revival, relationship, patterns, and trend. You can also find a trend analysis. I will also show you an example. Trends. For example, in USA, railway network, it is 1837. They started in 1833, and they are showing the trend patterns from 1833 to 2013. I will show you that image also. That is the trend. So GIS is particularly used for the data, very important. After that we require hardware, then we require software, then finally which one? Important. Finally it is required what? Users. Simply whenever we talk about GIS, it is the rely on data, hardware, software and users, which is to define the GIS, right? So this is the important part. For example, if you go for the basic concept zooming and panable, you know about the panning and zooming in map. Whenever you go for geospatial map, simply Google Map, you can pan it and zoom it, and you can also go for a drag. How many you have seen the 3D model? In Google, you have seen that if you want to visit the Pentagon House or maybe White House, maybe to go for in your London Bridge. Have you gone for that virtually? In AR VR, you can also see that one also very nicely. But in simply, you can download Google Earth and you can drag it your that image, the standing image is that, and you can visualize that one. Okay, that is the part of AR VR. And GIS is very important in that case, right? So this is with the zooming and the panning of images, right? And this is with the one pannable image, and this is very important map. See, fast GIS basically in geoinformatics, this mapping structure is in 1854. This is one of the historical image which is been captured by designed by Dr. John Snow. Okay, in 1854, cholera has been there is very just like corona, and so many people are dying for that things, but they are not getting any resolutions for that. Actually, mapping system is coming in 1857, 1854, right? So why you see the people which has been dying there, they are putting their dot. They are giving the dot. In one phase, they find out that in some spaces, you'll find they have one cluster is there, isn't it? So why they are putting the cluster there? So many people have died there, and they are finding the resolution that in that place one pipe has been broken there, and one pipe has been broken, and that pipe has been making the contamination with their water bodies. Then they are getting that cholera. So from that, this GIS concept has been widely they are using. Yes, US has been one of the US and Australia, and they are using GIS in every sectors. Their infrastructure management all has been very good in terms of USA and Australia. Nowadays in Saudi Arabia, Dubai, they are doing an excellent job in their mapping skills. Everything they are mapped with the 3D maps. They are making the 3D maps in every phases, right? This is the important map which is originated by the beginning of 1854 and by the Dr. John Snow. Okay, so from that phase we are having going for the GIS, right? So this is with the integrated map that every whatever I am telling about 3D features, they are giving the 3D model. They have the latitude, longitude is there. Then another is the which one? Another point is the height. They are giving the height. Okay, so that is also one trend analysis also they are seeing. In 1830 in USA, they are giving trend analysis of railway networks. See, 1847, then 1850, 57, they are giving 67, like this. They are giving the trend. And this type of work also you can do by using your web mapping features. If I will talk about in 1961, how many NITs are there? Then in 1981, how many NITs are there? 2001, they converted all having NITs, all RSS converted NITs, 2001, 2, 3, then giving this trend. So it is also visible or it is also very informative or not?
Yes.
So it is one of the technology behind this is very important. If I will tell you just make this one, it is unable to know where you can start, isn't it? So simply if I will tell about the things of overall world map, it is with a cross section of latitude and longitude. And all this latitude has been, longitude has been red line, and latitude has been black lines, right? And this longitude latitude is very important in terms of your Google in GIS technology. In geoinformatics technology, latitude longitude is very important. So purely, if I will tell about this one, in so many countries, they have their unique coordinate systems. But universally, publicly, if I will tell about the publicly system, then it is WGS 84. Again, I am telling that WGS stands for World Geographical Coordinate Systems. Because in 1984, they have decided that EPGS coordinate system there, they have one surveying group. They have telling that this is the final one for publicly. But the defense systems for America, for any other countries, their coordinate system different. You know that one. Their coordinate system will be different. You know, they are attacking to other countries with a specific coordinate system. They are attacking missiles You know, the best example is your Israel to that from that Iraq. So how they're tracking that one? They are using their own coordinate systems. Okay, but universally, publicly, all of you know about deep web technology. Whatever I'm delivering, or whatever you will know about these things, another 3 to 5 days, it is purely 2% of your cloud scenario. Another 90% where? Understand what I'm telling? Deep web technology, dark web, deep web, surface web. All of you know about that components. Whatever the cloud company you are delivering, whatever we are doing, only they have 2%. Surface web. Another 98%. 90% is purely on dark web. There is no any IP address, there is no anything, any sort of things. Only they are doing all these illegal things, all this API, FBI have been doing all these kind of things from that dark web mechanism. Or we have web, dark web, deep web. Then say whatever we are doing, they have all of it surface web. It has been registered by the Ministry of Regulations. Okay, and that deep web means we have given some security features. For example, in Gmail you can storing your data. In Dropbox also I have taken 100 GB of data. Everything in cloud they have given you some kind of data. So that is coming under the deep web. Deep web, because it has securely we have storing data. Surface web, deep web, and dark web. One book is that dark web mechanism book also is there. Okay, you can find out all this technology on that Tor browser. All of you know that. So through that you can you can find out. So 90% of your internet resources is purely dark. Only you know about that from Nabin Nivas to your what our
CB Raman.
CB Raman, right? Okay. So this is with the capturing coordinate systems. You can also find out the capturing, just you can put out some Google map. I'll show you how to capture the coordinate systems. maps.google.com. All of you know that one? हाँ?
UL and folder. UL folder.
हाँ ठीक है देखिए Google map. How to capture the coordinates? Just put the mouse there, right click on the get coordinates. Okay, so I want to find out the coordinate system of this. Here, okay, mouse is here, right click, get coordinate. This one. You just copy it, copies that one, and you can put paste on that. That is the latitude and longitude that has been given. All of it clear? So I can capture the coordinates, but you can also capture the coordinates some API also. Some API is that if you want to get all the restaurants from Bhubaneswar. One API can run, they can give the detail and they can put in one Excel sheet for your analysis. Right, all of you know about these concepts? I want to put all the hospitals in particular in our Bhubaneswar area. You can get one API and you can write the queries, all the schools or all the hospitals from there, they are captured and they capture all the details about that that coordinate also. Right? And you can get that coordinate and you can use that. For example, in terms of IoT concepts, you have to put, I want to put all these sensors, IoT, IoST sensors in every traffic. Then you can find out that coordinate system from that also, isn't it? And you can coordinate system from AWS, Amazon Web Services, you can calculate with that, I can get that details. And that detail has to become, and it has to be find out from that phase, right? So this is the part of how you can make the coordinate. Simply manually you can get the coordinates, isn't it? You can get the coordinates from that, or you can get from the APIs, or you can get from the IoST devices also. To get the coordinates, and it has to be get from that. All of it clear? So this is the way in which you can capture the coordinate systems. Coordinate is very important in terms of your geospatial techniques, right?
That will be the coordinate.
A map with the coordinate. That map has to be, yes. Another the map, Google Maps always following WGS 84. And whatever the coordinate is coming, it is also in WGS 84. It will be not match. If it is another coordinate system, then it will not map. If you map from Bhubaneswar, it will go to the Dubai. Understand? So if you collect the coordinate system, it should be in WGS 84 because Google, Yahoo, Bing, then Apple, all this has been defined with the proper one coordinate system, that is WGS 84. And whatever the sensor, whatever the data you have to collect from that, it is be coming from that WGS 84 coordinate systems. Right? Whatever I am telling, it is purely on WGS 84 APSG 3428 system. One fundamental concept is that we have to use that fundamental coordinate system. Just like in HTML, when you write the HTML, you have to open the tag and you have to close the tag. Like this, whatever we are doing, it is purely WGS 84 APSG. APSG is the petroleum group. European Petroleum Group is there. They are surveying in 1984. They are taking 1974 to 84 to get all this surveying mechanism for 10 years. After that, they are giving that one openly available for that to make that coordinate. So that coordinate system purely whatever the Zomato, Uber, Ola, whatever they are using, there is on WGS 84, right? Because that is the universal system which has to follow that. If you use other one, it will not map with your original one, right? So whenever you go for the data models, basically it is with the vector and raster. So in vector you can find out this is the vector format, this is the raster format. Raster means it is with pixel, vector is with the line point and polygon features, right? So in vector we have different type of file formats is there. Very important file format is the which one? My whole research area is on this vector. Sometimes I am using this raster for overlay analysis, but my whole work, whatever I am delivering or whatever the architecture we are following, use that work, whether it is cloud or web services or fog or maybe Mist or maybe serverless computing framework, I am always relying on which one? Vector data. Vector data means I am using these save files. Save files nothing else, it is with a combination of 5, how much? Combination of 4 file formats. So what is that? Now in save file, first of all we require project file, projections, WGS 84. Several thousands of projection file is there. That USA they have their own for defense system, they are using one projection system. Then UK they are defining all other systems. In India we have nothing else. Then in your you can find out in your other Australia, New Zealand they are using Angelic model. Angelic. Australia, New Zealand land influence systems, Angelic. You can find Google Angelic. Australia and New Zealand, they both combine together, they make their own coordinate system. But universally, we are using WGS 84 and it is with the one projection file is there, one .dbf, all of you know dbf database, go click on one point, they give the details by using .dbf. Another .shx, indexing. You know, spatial indexing is also very important. They have their own structures. So indexing also we require .shx. Then we have .shp, save file. .shp also very important part. That all these lines, point and polygons, point features, line and polygon, all these 2D features in our real world environment, it is be connected with 3 components. Point, you have to point data, you have to give point for additional locations, all these locations point, all the road networks, railway networks, river, they are going towards the line. Then ponds, area, all is polygon. So these 3 is very important for the representing of all these 2D features in your map. Okay, whenever you collect the data from IoT devices, all these conjugative line points if you get, that is with the line. If you get to one particular point from that IoT devices, it is with the pointer. Conjugative line, conjugative points, line. Conjugative points which is the starting and the end, different, they have been coming under the what? polygon features. So are you clear about this one? Safe file. Then we have also KML. Google app, they have their own file system. They have the KML, keyhole markup language. What? Keyhole markup language is be another format to use for the your geospatial analysis. They are using .kml. Several converter also there. You know, PDF to Word to PDF, PDF to PNG, PDF to that. So many tools also there. If you have safe file, they can convert it to KML. If it is KML, they can also convert it to safe file. Then KML to JDB. ISRI also is one of the big company. They are providing ArcGIS. Two friends are there. One is from ISRI, one is from the IDAS. So they are making one company of ISRI, but in after 5-10 years they are divided. One is coming from the one raster, another is from vector. So ISRI is now leading in the world in vector, and IDAS is be leading in raster. IDAS Apollo, they have ISRI ArcGIS. Okay, they have one cost around 1 lakh per one license. Okay, do you have here ArcGIS? Huh? No, no. So in ArcGIS, if you want to work in cloud platform, you have to ArcIMS. You require ArcIMS to do all these cloud infrastructure and all. We require ArcIMS. If you want to do IDAS, all these web features, cloud, fog, and you can integrate with IoT for data collection, and then we require IDAS Apollo. And it is very huge. The money for these two softwares for license, it make nowadays it is just coming less due to this cloud infrastructure. It is 1 lakh for license due to the cloud. But I am just telling about in 2011-12 we have purchased in NID Allahabad this in nearly 9 crore of 10 crores. They are still using for their work. You know our Mahakumbh Mela also there. They are mapping all this Mahakumbh 2025 in their own web server. Means they have 20, means they have making one district from that, and they have mapped. NIT Allahabad is mapping that Kumbh Mela structures, and they are putting web. So this it has Apollo structures, right? For this, you know, in two universities they have using the Param system. One is from IIT Bombay, another is NIT Allahabad. Because why? Rajiv Gandhi, you know that they have purchased Param system from Russia. One is from his home, another is from IIT Bombay. Because we have the Param lab in 1989. We have supercomputer at that time.
That Param Sabak, I think Param Sabak was developed by CITAC.
No, Param, that high performance computing system, which is supercomputing, they are first taking to Allahabad.
Okay.
Recently they developed by CITAC.
Recently they have developed, but the initial you can just Wikipedia, you can find fast supercomputing is coming to Allahabad, and one is from one going to IIT Bombay, and one is NIT Allahabad. Okay, so this is B part. All these vector and raster is very important for the geospatial data storage components. So fundamental GIS data is vector and raster. Vector is point, line, and polygon features also there, but raster is pixels. Right? So this is very important structures of the GIS database. So GIS database basically it is required the vector kind of, raster kind of. But whatever we have to do some demo, we are all whatever I am doing the research, it is purely based upon the vector database. All be clear, vector is purely required for all this routing analysis, all this analysis for the storing purpose, visualization purpose, we have to use this vector data concepts. Right? So point for vector point pair of the x and y coordinates, lines is the series of points connected together. All these point has been connected, it is the line, so they have a series of points of connected together. Right? But whenever we talk about the polygons, a line enclosed from the end to end. Right? Then if you talk about point, all the cities of USA, map with the point cities. If you talk about line road, all these USS road network systems. And if you talk about polygon, these structures. Right? State features, we have to go in for the polygon. Then line features, it is be in lines, right? And all the cities has to be mapped with the point. So are you clear about this one? Database set is clear. This data set is very important, and we have to put forward in your cloud, fog, mist environment to visualize the data. So it is clear, all of you? Any doubt regarding this?
No.
So it is specifically .save file is there, right? So vector GIS data, it is all about that. Attribute table is very important. But because you have connected with your .shp, .shx, .dbf, .project, PRG. So whenever you have to click on a particular point, it will give their table with their attribute structures. Because we have already integrated with the tables, so that attribute has to be give to the cities. Click on that, they are giving this one. I'll show the demo. If you click on that particular point, it will give the details about that point features. If you click on line, then it will also give their structures. Isn't they are giving the street structures, point where series type of things are given, right? Then similarly, you have to give attribute for steps, that is polygon. All of you clear about the related attributes? Click on that, it will give their structures, their table structures. And the linking is also very important. For linking, we have also so many algorithms also there. How you can fastly link with that? So many algorithms, A star algorithm, R star algorithm is there to linking with your features to their database. Okay. And you will find out this one spatial database. One book is there specifically. It has been written by the Sasi Sekhar, and it is the Sasi. You know, spatial database. Sasi Sekhar is from Mississippi University. Okay, he has one Bible book of spatial database. Nobody has written that book except that kid. He is from India, and that book is just like in your database Ramkrishnan book. All of you know that it is be also purely they have giving mathematical things, isn't it? Similarly, spatial database is purely written by him, and they are given how it has been stored in that. Purely they are given how what are the algorithms is there, what are the algorithms required to store frequently or the data set files, right? So now, so raster, how can you define? Raster will also be defined with the point as a 1 pixel. The line of number of points has been given with the neighboring points coming out in the given directions. That is also the consecutive pixels are there. Then polygon and integrations of neighboring pixels. This is the points, green points. All these neighboring points is been coming under 1 pixels, right? So this is be the raster base. So there are different database structures required, starting hierarchical database to network, relational, object oriented. All if you know about that, that is the basic fundamental concept in which you can use for the storing of database either in a hierarchical manner or maybe object relational manner. All these polymorphism, inheritance kind of things, or maybe you can use here. You can find out that hierarchical inheritance is very important in that, or multi-level inheritance also be one of the important part to storing all the geospatial database, right? So you can also do some of the queries also. Queries also be a very important one, attribute queries and geospatial queries. Just you know, one linking with that attribute. If you go for the doing some oracle type of queries, that is attribute. If you do some geospatial queries, that is the other things. I'm just telling you about their difference also. So this is with attribute queries. If you click on that, it will give the details. Query is that select areas where the mortality rate is 58.0. So that is given on that. You can visualize this one in cloud platform also. You can write the queries, it will give the details about that black color, which is the mortality rate is 58, greater than 58. If you come, so the queries on the, click on that, if you click on that, it will give this details. It is be known as the geospatial queries, which is be coming from the lung disease in 1860s. Okay, so this is be known as the geospatial queries. Mapping through the attribute queries also you can find that this is one with the structures. Then analysis, you can do two types of analysis, the overlay analysis and buffer layer. Overlay analysis, that one layer is there. How many you know about to map with the Adobe Photoshop? All of you know about Adobe Photoshop?
Yes, sir.
So they have layer wise structures is there. One layer is given. For example, if I will tell this is be the one images, how many layers you will find from this? For my expectation, it is with the maybe 4 layers. One is the black is there, then white, then one green is there, one what? Blue is there. But if somebody is saying that we have also written one, there also one images also. So they have 6 to 8 layer you can expect from yourself. isn't it? Similarly, if you find the layer-wise structures, one shape file is embedded with the other shape file, layer-wise, then this is coming under overlay analysis. For layer, one data is coming from 950, another layer data which is be 951. So they are coming for the overlay. One layer with another layer. I'll show you that example also, right? So that also you can find out in Google Maps also, right? The overlay analysis, vector and raster. In vector analysis, you can do that forest patches is there, another is the slope, and it integrate with the forest and slope. This is one vector over there, right? Another one is the raster layer. Pixel, 2 pixels is there. Soil, it is the 2 pixels, and cover type. Then AF, BF, BF, AG, and BG. They are the pixel has been embedded and it is been known as the raster over. Right? 2 layer is there. One is soil layer or cover type. The map with that is becoming another. Which one? So this is buffer analysis is very important. For example, in our Bhubaneswar municipality, you know, they have their own line network. They have analyzed that 5 feet from left, 5 feet from right. How many tobacco wine shop has been there to remove that tobacco, that wine shop? So how can they analyze that one? Right? Buffer and understand what I am telling. The example in one road network, some municipality is giving that you just remove all these wine shop, which is be 5 feet within that 5 feet from left and from right. So they do which type of analysis? Buffer analysis. Buffer. They are in line 5 feet from left, 5 feet from means 10 feet buffer they have created, and they find out how many wine shop is there. Understand the concepts? So that is also one of the good analysis for that. And another point is that in our Bhubaneswar University, I want to see from 100-meter radius how many wine shops are there. They can analyze that one, isn't it? You will find more in our university there, isn't it? So this is with the things. University radius, this is with the buffer from 50 meter here, from 50 meter there, isn't it? And then this is with the network. In our Puri, for example, Puri Mandir radius, how many mutt are there and they are demolished from there. They can analysis from that also, isn't it? So this is be the one polygon features analysis, polygon based buffer analysis. This is be the point based buffer analysis, and this is be the line based. All be clear? Can you give another any example where you can use that point based buffer analysis? Any example? Point based buffer analysis. I have just given one example that in school in 50-meter radius, how many tobacco soap is there? We have to remove that. Any other example that you can use that buffer analysis point wise? How many mandir is there? Temple is there from that 100-meter radius from this C.V. Raman University. That is also one type of buffer analysis, right? Okay, all be clear. This is the fundamental idea. Whatever we have to understand that this is the GIS, simple GIS data set. We can do this data set is purely .ssp file data set we have using for vector data purpose, and we have to perform some of the analysis, either buffer analysis or maybe that overlay analysis. Overlay means one layer is there, another layer we have to input there. So this is the overall idea about the basic structures of geospatial data sets, right? And their applications. So after that, the main thing is that what are the computing paradigm we have, starting from your mainframe to serverless. We have ready for that. It is be purely fixed. The data set is fixed. Data is be there. But how that framework is be very much useful to do all kind of work, right? So we have one time frame is that this is the time frame, mainframe, Initial phase we are using mainframe, client server, web services, SOA, cloud, fog, mist and services. So anybody having any idea about from that beginning? So which having any idea? Just tell me which one is your particularly acquainted with that. Those having done their BTech in 2007, maybe 8, they are in syllabus SOA also there, service oriented architectures. Huh? SOA, it is purely one type of course structure. It is violated, man. It is outdated. So, can anybody can explain about what is the difference between these two? What is the difference between these two? Client server and web services. Is it the right path for the cloud or is there any missing from that? Anybody else tell me? Is there any missing structure is there, or is it purely authenticate or purely computing components is there? All of you understand what I am telling? Starting ରୁ ନେଇକି end ପର୍ଯ୍ୟନ୍ତ ଏବେ ଯୋଉଟା ଚାଲିଛି exactly edge computing is nothing else, it is also the IoT layer. Somebody edge computing, DU computing, osmo computing, you can find lots of papers. Osmo computing, DU computing, jungle computing, tree computing.
Fog computing different in the cloud computing.
Cloud 2008
Oh, scenario.
First mainframe, then you will have client server, isn't it? Any other things which is missing here, or it may be there? See, edge computing के बाद दे चंदी बहुत सारे कौन कर चंदी ना? Yes, we are not considering fog. We are not considering fog. Customer we are about अलगा दो, or then another जो researcher they are, because you know in our intellectual property mass, they are telling they are the best, but no one the best. Understand? They are telling that no. Why they are telling fog? Somebody is coming. No, we are not considering fog. We are considering edge computing. Yeah, kitchen है that. They all are only, all are same structures. Some ID Bombay say that what are you doing? Cloud is purely validation. That simple structure is standalone pieces because that security concern is there, na? But cloud also is required, isn't it? So because for example, pay per use model. So simply you all of you know that cloud computing system is purely based upon the IPS. You all of you know about the meaning of IPS. It is simple structure. If cloud is there, IPS is there. Why I am telling IPS? Because IPS for full form is very जो बुझिए मन रखे में भलो माने मन रही IPS officer is there, isn't it? So IPS, infrastructure, platform and service. एमती कोई मन रखते हैं. Cloud is purely IPS, isn't it? Infrastructure, platform, service. Somebody is telling no sir, I know that database as a services also there. Understand what I am telling? IPS, all of you clear? IPS, infrastructure, first we require infrastructure, after that we get platform, then top of that software as a service. Software as a service. So you can understand that one. So whenever taking any class from cloud computing, I am telling that you just remember that IPS. Infrastructure, just talk about that. Huh? ISS, PSS, but nowadays X as a services, XSS is also there. Anything as a services, but the fundamental concept is that you have to find out the infrastructure required. Then you know about the 10th V also be there from if you talk about big data. 10th V, but to simplify you have 3 V's, isn't it? Similarly, if you find about the infrastructure, if you're talking about a cloud computing service model, it is IPS. Infrastructure, platform and service. Right? So in infrastructure, you have to collect your infrastructure, you have to find out what are the hardware requirements, put on that, what are the services, what are the memory devices required, what are the virtualization machine system you have required. After that, you have to choose the platform, what type of, whether it is be the Windows platform or whether it is be the your Macintosh platform or any platform you require. Then what type of software you have to require, what are the application software you require. Then somebody is telling that no sir, all these database is coming one service, because we have 10 to 12 different type of database required. Maybe for my work, geospatial work, geospatial database, if you want to store, you require one is that Oracle Spatial, they have their own. Then you can use PostgreSQL, there PostgreSQL is there. Then you have Microsoft, they have also their own Spatial also there. Okay, pandas also they have, GeoPandas also there. So all these service, all these pay-per-use model has been there. They have integrated. They are telling the database as a service. Then somebody is telling, no sir, we have all this machine learning has been there, and we can take as a service. So machine learning as a service. All this type of machine learning classification, clustering algorithms is there in one platform. Very as a service. So okay, so I am just telling about, just tell me about what is the difference between client server and web services. I will share one research paper enabling web technologies. One survey paper is that they are telling from web 1.0 to web 3.0. So what is the difference between that? Anybody else having know about what is the difference of web 1.0, web 2.0 and web 3.0?
Web 1.0 only for the read only. That means
only you can read the instructions. Just like all this HTML, static HTML page. It is only static HTML page. You know about the visiting card? Online visiting card. Just you write the HTML page and you have to give all the instructions and just read on. If you do both read and write, then that is web 2.0. All this cloud, fog is coming under that. But what is the web 3.0?
customize.
Any other? Security concerns also be there. I am showing one paper's detail.
Security concern web 4.0.
Web 3.0, I am showing that figure.
Sir, can you add your quantum computing also?
I am showing that one. Huh? This one. See, this is be the one model which is be taken from one research paper, one transaction paper. Web 1.0, 2.0, 3.0. What are you telling? The static read-only web page. Here you can find read-only basic web page, HTML, e-commerce, Java, JavaScript, dedicated infrastructure, banner apps. Similarly, if you find out in terms of your web 2.0, information center and interactive, right? Read and write. Read only, and another is the own. Your own infrastructure. Own, how you can get? By using this. See, this is Google, MSN, this all of is coming under which one? This read-only structures. Just like iOS, YouTube, both read and what is that? Meta. Then browser, this is Twitter, then your Wikipedia, Dropbox, Netflix, Android, they all are coming under the web 2.0 and it is being like this. Then in 12.2 now, we are using this like consortium and all. That means it is be the metaverse, blockchains, all has been coming under the user-centric decentralized security. Is it clear? Own is one of the important features where security concerns is also there. This is with the latest paper from one transaction paper. I have taken this images, right? I will also share this paper also, right?
Yes.
So this is be the for the see the themes is your IoT design and application scenario. This is be the main important part for your research area for this topic. Understand? All be clear about this point? IoT is see, IoT also be part of this web 3.0 due to this one cloud. This IoT is related to blockchain also. Isn't it? You can find thousands of IoT assisted blockchain environment. IoST assisted fog and blockchain environment. So IoT is rely on with blockchain due to the security concerns. Okay, so this is be part of your Web 3.0. Whatever you think IoT blockchain, you can put a miscellany on that. This is be on paper. Understand? So okay, so all of you clear about this one? So we'll go for all these structures step by step. So before that, so in that in two to now we have to cover up with one. Huh? Article ଆମେ next session ରେ define କରିବା ଯୋଉ କେତେବେଳେ launch ପରେ ହେଲା ମୁଁ ଏଇଟା କହିଲା ପରେ ସେଇ article ଟା ବୁଝି ପାରିବି ଆଉ article is nothing else, it is to cover up with that things. Whatever I am telling in that article, you will find about the details about this one. And another one, that performance evaluations, it is be the part of your queuing model that is be done by my another collaborations. I will tell about these things, and I will tell about how you can do this type of work, and you have to put one good journal also, right? Journal paper writing is very important. It has the proper block structure also there. I will tell that one, or I will tell that one. Then again, we have to shift these things in 232 onwards. Huh? So now before we go for that technological paradigms, we have to know about geospatial web services, because in cloud, fog and all, in terms of invoking all this data, we require some web services, isn't it? We have to list down, we have to collect all different type of web services so that we can do our work. So in terms of our geospatial web services, we have to implement in two ways. Basically, it has three ways, but we have to consider about two ways. One is the thin client and thick client. So any idea about thin and thick client? What is the difference between thin and thick client? What is the difference between thick and thin client? Any idea? Simple general questions. Thin and thick is that if you do any web services, to invoke any web services, we haven't required any additional software. We haven't required any additional software to visualize or to invoke that web services. But if you require any extra apps or extra plugins for visualizing the data, we require thick. So give one example where you require thin and thick. How many you are using the Dropbox? How many you are using? How many you are using Overleaf? Overleaf use करते हैं? Premium versions you have? Huh? So in Overleaf, can you do in desktop base? Or you are only doing in the client base? It means in a browser base, isn't it? You are using a browser. No need to add any extra software, isn't it? So that is thin client activity. But whenever you use the Dropbox, you have to install that one. You know about Google Drive you are using? You have to download that Google Drive and you are installing your system. Then you are using that one. Again, you can also use from your Google Drive browser. If you are using browsers, it is coming under your where? Browser thin. But whenever you have to use in your installation of software, that is
Thick client.
so which one is much more benefit according to your scenario? If you are working in your system, okay, thick is very good because it is part of your mist computing architecture.
Sir, suppose we have go for the collaborative work, then thin client is better.
You can also go for the thick client architecture also. You can right click on that, you can share with give your email address and it will be shared to the others also. Understand what I'm telling? So similarly, in my Dropbox, I will also show you that I have my scholar, each and every scholar I have sharing one Dropbox folder in thick client. they whatever they're doing, I am monitoring from there. Understand what I'm telling? So you can monitor from that also.
Google Drive.
Google Drive also. Means in thin and thick line. But another point is that if you talk about the Google in the geospatial technology, Google Map and Google Earth. Google Map, it is purely thin line. You don't need to require any extra software. But Google Earth, you require API or you require one plugin to use that Google Earth. Right? Also clear about this one? Thin client, thick client, very important in terms of your cloud infrastructure or IoT-based infrastructure. According to your requirement, you can use either thick or thin. Another one is very also important thing is that mobile client environment. How many thick client required? Mobile client, thin client,
Thick client.
so mobile client, all of you know, I can use the Dropbox through my mobile also. I can access all these papers whenever I am free. I can access. I can read all these papers through my mobile. I can install one app and you can see from Google Drive, maybe your Dropbox. You can use Box. You can use OneDrive. All you can use by your mobile also. So how many client architecture is there? Three. Mobile client, thin client, thick client. Right. So this is very important structures for the web services. So this is with a simple architecture, thin client architecture. You can use web browsers, internet, web server. Web server is in where? It is not in client side. It is in their server side. Web server is, but thin client, it is be part of your thin. That web server also be part in your client side. That is the basic difference. All of you clear? Any doubt? So in thin client, so we have what? 4 varieties of web services. Geospatial web services has been defined with the 4 services. One is the web map service, web coverage service, web feature service, web registry service. Means whatever the services has been defined or invoked, it has been listed down in register services. Register. So that is web registry services. Web map services is that the map which you only visualize, you cannot get the detail about that. If you click on that, you will not get any details. Just like satellite images. Satellite images, if you see from your browser, it is purely one type of web map service. You cannot get anything else. But if you mouse over on that, you will get the coordinate system, that is web coverage services. So coordinate is very important. So that we have to add another coordinate system with the images. So that is coming under the web coverage services. If I click on that, you will get the detail that is coming under the web feature services. So are you clear about the basic idea about these features? If I'll tell everything else, if I will go for web map service, it will take around 2 days. If you take detail about web coverage service, it is also taking this. Then finally, this web feature services is very important for my researcher. Or I am working on this only web feature services. And it is take also be 2 days to define all these web feature services. Each and every services is one research paper. To surveying all these web map services, you can download 50 papers and you can summarize web map services in the field of geospatial technology. It is one essay exam. If you put web feature services for last 10 years work, it is one paper. 10 years of web map services. I will tell you about that also, how to write the good papers. If you are telling, sir, we haven't any infrastructure, we haven't any type of resources. What we will do? We have not anything else in our university. No. If you have your own things, then you can do that. Means one of the best techniques to write the research paper is a bibliographic analysis. You heard the Akash sir will come last day. He will tell about the things how can do research without any paper or anything else. Bibliographic analysis. 2 tools is there, IoST and but another is the IoST one software is there. Another is your I am just forgetting that tools. You can just download that data set, put that in the tools, and you will get attractive figures. Put on that, you can write all these paper details, and you can get that. Okay, so biosphere, side space. Side space is Akash, you will tell about these things, and everybody, whatever you are, Here you have to write one paper. If you have any doubt, you just contact me. I'll do that paper in SCA journals. Understand? So if I will tell what is your overall, what is your research area? Tell me your research area. Intrusion detections. You just write down in Scopus. If you have Scopus database is that intrusion detections in fog environment. Intrusion detection plus fog computing. You will get 15,000 paper. 15,000 from last 10 years. You will just put 2014 to 2024. Download that data set and do one thing. So you just put on that site space or VSBR, or you just do the train data. Train, understand what is the meaning of train data? Just you can collect up to 800 papers. Just train it and put on that, and you will get attractive figures. And there are so many templates also that I will also share, or maybe Akash will be share on that.
Site space template. Oh, the
Paper writing is a template.
that is available on the site space also.
No. Paper writing.
Oh,
Paper writing template is there. What you will put next? Understand? So that is also very important. You know why it is important? I am just telling you in a lighter way, but it is very important because whenever you do any kind of research, first of all, the selection of the journal paper is very important. Although you know those are doing PhD in nowadays, they are telling the sir also download me 5 papers. I have done that one from 5 papers. It is purely wrong one. Also, my PhD I have reviewed 138 papers in 2012, and they are telling you how many journal paper, how many book chapters. There is no any conference paper. Conference paper is purely valueless. You cannot put any conference, although it is be purely from USA, or it is be 40 edition, 30 editions. If it is be the conference, then you have to use in your PhD. Understand? Bibliographic analysis is also very important because selection of journal is very important. There you can find out 800 papers. From that 800 papers, you will collect from last 10 years paper. That 10 years paper means it is be around 175. From 175, you have to fix it that this is for 120 papers for my research work. Then that 120 papers will be collect. From that 800 paper, you will write the bibliography analysis. From that 120 papers, you write the proper review. So in one actions, you can get 2 papers. Although it is the SCA journal, you will also get the transaction also. I will show you the transaction paper also there. In bibliography analysis, you will get the transaction paper. Intrusion detection in fog environment. To detect anomaly detections, or you can get in healthcare environment. You can put 3 parameters. You will get the paper, put into their web site space or VSBR. Do it that one. Then after that, collect 120 papers, just write the normal review papers. Just complete it. After review, you can find out what are the main loopholes on that. Then you can find out the three research objective. Then one by one we have to do it, and you got good papers on that. Understand? So everywhere that type of concept is running. So bibliography, the last session, the last day session is very attractive, and you just do that one also. Okay, bibliography analysis on that. So I have 5 to 6 paper only bibliography analysis. This 2024 I have 28 papers. In that I have 3 to 4 papers in bibliography analysis for my PhD students. Okay. So web map services, as I have already discussed about that, you can refer only that map provides the image files, graphics language like SVG and GeoTIFF image. TIFF image is there, but if you put the coordinate system, that is coming under GeoTIFF. The OGC web map service also be there, which is providing maps, and it is the spatial reference data dynamically. That is with the web map services. Another one point is that you can find out web map service enables the creations of the network of distributed map servers, and also you can find web map service operations can be invoked using the standard web browsers. So web map services, it is coming from that web browsers only. But you cannot get any details, only you can find the image. Whatever the image you have downloaded, you can visualize through that web browsers. That is web map services. And just one example, I am just showing how you can find out the web map services. This is simply one web map services where you can get only the maps. Will not get, if you click on that, you will not get anything else. And you know that is the famous tag. If you put the drag and drop, you can get the 3D images. But this is with a purely one type of, but only images without any properties. If you get their properties, then another web services we have to invoke. That is web coverage services. So web coverage return the coverage data, means it is giving the coordinate systems, and it is purely return the actual raster data. And OGC Open Geospatial Consortium is there. They have listed down thousands of web services. So apart from that thousands of services, I have categorized into 4 important services. Starting web map services, web coverage services, web feature services, web catalog services, right? So these are the main important coverage services. I'm just giving one example that how can you find out web coverage services. This is with the web coverage services, and you just palm it, you get this coordinate latitude and longitude and latitude. Okay, this is with the one web coverage services, right? The difference of all of it clear. Web map only map, web coverages you have to find out their latitude and longitude. Then web feature services, it is be giving the vector data. There it has been only giving the raster with coordinates. Only raster data, web map, along with coordinates, web coverage services. But here you can find out the raster data. And in raster data, you can find out the standards which are provided and interface along the request for the geographic features. It is giving the features because you know that save file have been integrated with the 4 components. One is the .shp, .shx, .dbf, .project. So that dbf file has to be connect for these web feature services, right? So it has been define the interface for the data access and manipulations operations in a geographic features using HTTP or HTTPS, right? So this is the one example. This is my one my MTech thesis. I have taken this image that I have getting all these NITs in year 2009. That all this old NITs has been mapped, and if you click on that, it will give all the details about. Okay, it is giving the detail about all these NITs which is coming on the selected areas, right? So India boundary also there, and states there, any location. In locations, click on that, it will give the details. That is coming under the web feature services. Then last one is very important. What are the web services you have designed? You have to list down in your registry services. One list down of registry services. So I am just showing you that they are features. Then where the service presents many metadata. Metadata has been synchronized in your systems, and it has been linked with that actual web services. This is the metadata repository is there. Here the application client is there, and it has been catalog services there. They have been requesting the metadata services, and they get the response. And from that, the resources are to be linked with that resources. This is with the actual models for the web registry services, right? So in demo, I'll show you the web feature services, right? In a IoST Mist Fog Cloud environment, I have to invoke one web service, that is the web feature services, right? So web feature services means click on that, we'll get the details. Google Maps is all about, it is showing the 4 services. They have the catalog services is there, only map services also there, coverage services there, and features also there. If you click on that one particular point, they are giving the details, isn't it? They are giving the image, they are giving the details. So that feature is coming under the web feature services, right? Web registry is there. This is the also I have in 2009. This is with GeoNID systems. There I have stored all this metadata here. This is the part of web registry services. See, it is with the local host. They have taken in through the local host. Simple web services invocations can be done through the geo server. It is one type of geo server where we have defined all these availability of data sources, and we have to link on that. They will go to the actual services. If I have thousands of web services there, I will list them there. You just click out to search out which one is the requirement. Then you click on that, it will go to the actual web services. That is known as a web registry services. It is very important for the cloud and serverless computing environment. Okay, in terms of geospatial web services, we have this type of component is there, right? So again, I am also telling about the thick line. Thick line means here We have required extra modules which has been installed here. For example, plugins, Java players, JavaScript, ActiveX, all has been installed where? In your client side. Similarly, we have also installed in our server side. So that is the thick line architecture. So it is purely coming under the client server, and another is a web services. After web services, what do we have the next computing things? Service oriented. So service oriented architecture. I am just showing you how the service oriented architecture has been playing in geospatial components. So that is known as geospatial SOA. Right? So in geospatial SOA we have the architecture. See, in geospatial SOA we have 3 layers. Important layer. Consumers, that is with the applications layer. This is with the storage producer layer. Consumers and producers. Actually in SOA, it is purely, it has been outdated in 2012, it has been outdated. SOA, we have 3 components. Find, then bound, then registry. 3 structure is there. Isn't it? So consumer consuming the services. Consumer, what they are doing? Consuming the services. Which has been provided by the producers. Consumers, yes, producer. How can we get the producer? By our data set, RDBMS. Then flat files, you know, we store the flat file systems. Different search engine also there. Then hosting provider, those are hosting the services different ways. Then enter the application servers. That dedicated server which is doing the part. For example, I only want to work in web feature services. I have dedicated web services or that dedicated application server which only doing that web feature services. If I have one web map services, I have dedicated web map server is there. Isn't it? You will see in your in IRS Dehradun, they have different server is there. Only one server is there. They only is collecting the data. They are doing web map services. Only they are storing the satellite images. Nothing else. They are storing the map service. Another one dedicated server is there. They are the postal GIS. I will show you that demo also. They have also designed the Indian postal GIS. All this India, how much postal network is there? They have designed that one. IRS Dehradun. So they have one dedicated server is there. They only accessing all this postal network in India. School survey, all this Kendriya Vidyalaya also network by GIS. They have also designed that one also. They have also dedicated server is there. They are doing web feature services. That server is only accessing that one. All this Kendriya Vidyalaya has been connected with the GIS. So they are also doing that type of work also. Okay. So all of it clear. In that consumer we have desktop with live, then web browsers, mobile devices. You know about the service calling services? One server is to be connected to another server. For example, Google, what they are doing? They are doing this type of thing. Service coming in service. Isn't it? Service to service. N services, service to service. Isn't it? They are nothing else. They are doing the service to service. Just like Amazon having their own warehouse. Their own warehouse, nothing else. Service to service. Exactly they are doing. This is also one consumer kind of thing. Portlets, they have also given some portlets. That means I have one, my own browser is there. I have connected one API with where is my location? Google Maps has been embedded on that, and I put it one map. This is my working place. So one API also integrated on that. So that is the part of your portlets. Then this is very important part. Applications. All this work from consumer to producer, it has been mapped with this one. One is your rich clients, web apps, mobile apps. That is part of your applications. What are the service support they are doing? We are doing directory, then you have security, they have management, orchestrations. One services to the another service they have mapped. Choreography also be there. All this coming under this service support part. Then your semantics. And here all these data centric services has been there. See, map services, OpenGIS services, image services, analysis modeling, they are doing all this. All has been coming under business centric work. Okay, this is your geospatial, but your service oriented architecture based services. After the SOA, what you will be find out in your work? That is coming under your geospatial cloud is very, or it is be in some cases you find a spatial cloud computing. Okay, one book till now we have only 2 books is there. One is dedicated for vector. That in 2013 they have produced one book, Spatial Cloud Computing, and they are updated in 2017. I will also share, if somebody have interest, I will also share that book also, 2017. That book is purely dedicated for the Spatial Cloud Computing for the vector. Another book is there in 2020, they have defined that cloud computing for remote sensing images, satellite images processing. They are using all infrastructure, they are only for the raster images, right? So I am just showing you that geospatial cloud, which is my favorite or my research area from last 12 years. Okay, I have make my own cloud system, cloud geospatial cloud network, and I have integrated all these data sets or different application areas. I would work in health GIS, even though in our your education sector GIS, in electrical grid, smart grid computing GIS, everywhere I have using my this system framework. Okay, so the basically geospatial cloud computing is that it has been providing compute resources and services with the help of the network connection. Simple definitions of simple, which is being used for the cloud network, cloud systems. It handles huge storage capacity, isn't it? Whatever the, because geospatial data itself is purely high. One certain image, it will be simple one area, it has been 1 GB to 10 GB of data. One satellite image for one day maybe. Okay, 10 GB of data. So it is be huge. So it is required to handle the huge storage data. It enables faster scalability. Scalability also very important part, and lower the cost of analytics. Because when, for example, if you take one ArcGIS to install in the system, and if you do for the cloud environment, it is purely less, isn't it? Pay-per-use model you can use, and you can get it done by that. If you purchase it, it will take around 10x, more than 10x, isn't it? So less control about security, but the main important is that less control. There is no any security mechanism for this cloud. So the general structure of the cloud system is that. So see, it has also 3-layer system. Clients, see, I already mobile clients, big clients, and big clients. See, they have this logo is Quantum GIS. This is with the grass. This is with another software which is integrated with that. For example, you can install the Quantum GIS and do all this work for the client section, and you have to invoke with the cloud. That is your thick client. Thin client is that which is the map which is be defined, and it has to be all the browsers is there, and your map ender, all these are there. We have to access, we have to connect with this data, isn't it? Then data layer, line layer to data layer. Data layer we can find file system, metadata, and data analysis is there. This is the PostGIS logo. PostGIS data analysis tool, and this is the important part where you can use all these services. See, web server, you can use this catalog service, CSW catalog services, data services, web map services, web feature services, web coverage services. All these 3 services coming under data services. Then another part you have processing, web processing services is there. All this machine learning mechanism, all this type of job, analysis job is coming under this web processing services, right? So then we have dedicated server for dedicated catalog. For catalog reason, we have using catalog server. For this data service, we have involving all these web map, web feature, web is dedicated to one server, and all this processing we have to perform from this. We have dedicated web server, and it is the processing has been done with it. You can use R, you can use any type of GeoDAL, GeoTools, Java, Python, GeoPython or GeoSpatial Python is there. You have to dedicate, you have to work on this. So this is the overall architecture of geospatial cloud environments, right? For geospatial cloud environment, they have so only few cloud providers which are working on this geospatial cloud computing environments, right? So we have to cover up with these things. After launch, we will go for the another fog environment and all these other environments. Okay, right? Did I start to do it? Kind of, यहाँ पे ना मैं 5 start
As we conclude our first session of today, I would like to extend my sincere thanks to Dr. Bari for delivering such an enduring and insightful session. The knowledge shared was truly enriching, and we are grateful for this valuable contribution. We will now take a short break for lunch. I request all the participants to kindly proceed to the lunch area and enjoy the pleasant break. Thank you. Uh-huh. Please be mindful of the time and return promptly for the next session. Thank you.
ये चालू करें